Alright, let's look at some more quadratic equations and how we can sketch them, but today using the quadratic formula. So if you can't quite remember, the quadratic formula, when we start with the general equation of a quadratic, and we want to find the roots, well, we know the roots exist when y is equal to 0. So we might just say, 0 is equal to ax squared plus bx plus c. And in fact, some Flemish guy during the Renaissance period did say this. He said, well, what if I set y is equal to 0 and I try rearrange for x? So instead of factorizing my quadratics every time to solve them, I just have a formula to tell me what my roots are. So if I take this general quadratic and I rearrange it for x, it gives me something of the form minus b plus or minus the square root of b squared minus 4ac over 2a. Okay, so if I've got this quadratic formula and I'm looking at a quadratic equation, y is equal to 2x squared plus 4x take 3. I'll just write that down too, because why not? I can just substitute my a, b, and my c, remembering to include the signs in front of my a, b, and c as well. I can just substitute those values into my quadratic equation. So we'll see you get something like this. X is going to be equal to negative b plus or minus b squared. 4 squared is 16. Subtract 4 a c on 2a, and I'm just going to write that as 4 squared, and let's just simplify this in our next step. So it'll be minus 4 plus or minus 16 take, well, negative 4 times 2 is negative 8. Negative 8 times negative 3 is 24. So that will be negative 4 times 2 is negative 8. Negative 8 times negative 3 is positive 24. And that's going to be over 4. And so 16 plus 24, that's 40. 16 plus 24, yep, it's 40. And while I'm at it, I might just separate this out into two fractions. Just split the denominator to make this into two fractions. So I've got minus 4 on 4 plus or minus root 40 on 4. Well, minus 4 on 4, that's just negative 1. Plus or minus root 40 on 4, well, root 40, I could express that as 4 times 10, or root 4 times root 10. So that will simplify to 2 root 10. So I can say plus or minus 2 root 10 over 4. And then 2 and 4 will simplify to 1 on 2. Okay, so I've got my solutions for x. And remember, now that we've got some context, this is x when y is equal to 0. So these are in fact my x roots, these two values here. And just to write them out plainly, it's going to be minus 1 plus root 10 on 2. So when x is this value, that's going to be an x-intercept. And when x is this value, minus 1 minus root 10 on 2, we're going to have another x-intercept. Okay, so if we sketch that out, well, one thing we can kind of recognize is that our two x-intercepts are plus or minus some distance from negative 1 along x. So if I just chuck in negative 1 along my x-axis, I know that I've got some root that is root 10 on 2 below, and root 10 on 2 above. So let me just quickly check whether if I say minus 1 plus root 10 on 2, this is going to give us about 0.6. So that's going to be over into the positive x-axis here. So we can see a quadratic is going to be roughly something like this. Where we are we are root 10 on 2 below minus 1, and we are root 10 on 2 above minus 1. So I'm not even putting in numbers on the axis, I'm just sketching this out. And well, because we're give or take this distance from -1, that means -1 is our axis of symmetry, right? That's actually the value of x at the turning point. So if I want to find the coordinate of this turning point now, I know it's when x is equal to -1. So let me just use that in my original equation. Y is equal to 2x squared plus 4x take 3. If I say x was -1, so turning point, value of y is going to be 2 times -1 squared plus 4 times -1 take 3. 2 times -1 squared, that's just going to be 2. 4 times -1 is -4. Take 3. So -2, 3, 4, 5. So y is going to be -5 at the turning point. So we can mark in -1, 5. Oh, sorry, -1, -5. Rewrite that. -1, -5. And the last key feature that we need to worry about is this y-intercept here. So I wasn't too good here. I don't know whether this y-intercept is in the negative y range. It's possible that we have something that looks like this and we intersect in the positive y range, but let's just check it out, shall we? So the y-intercept occurs when x is equal to 0. So if I'm looking at my y-int, that's when x is equal to 0. And so just looking at this equation, I can see if x is equal to 0, well, that's going to be 0, that's going to be 0. My y-intercept is going to be at -3. So we're actually not too bad here. This is going to be -3 along y. Okay, so our quadratic looks something like that. Let's look at one more. So here is another one. 3x squared takes 6x plus 1. I'm just going to substitute a, b, and c straight into my quadratic formula. So x is equal to b, well, negative b. So negative of -6 is going to be positive 6. Well, let's write it out in full first. So negative b plus or minus the square root of b squared, well, -6 squared, take 4ac, 4 times a times c. Oops. And that's going to be over 2a. Okay, so negative of -6 is positive 6, plus or minus 6 squared, -6 squared is positive 36, and minus 4 times 3 is 12, times 1, that's just going to be minus 12, and that's going to be over 2 times 3, which is 6. So again, in the next line, I'm going to split this up into 2 fractions. And remember, the reason I like doing that is because now I've got some distance above or below my turning point, or my axis of symmetry. So let's say axis of symmetry. And then we're plus or minus 36 take 12, 26, 25, 24, 24 over 6, and 6 on 6, of course, is 1. So it's going to be 1, give or take 24. 24 divided by 4 is 6. So we could write root 24 as root 4 times root, well, we could write it as root 4 times 6, which we could then write as root 4 times root 6, which would be 2 root 6. So I'm going to say plus or minus 2 root 6 over 6. And we could kind of simplify this root 6 in 6, but that would lead to us having a root 6 in the denominator. So let's just leave it as it is. So 1 is our midpoint, or our axis of symmetry, and our roots are, give or take, 2 root 6 on 6 above and below 1. So let's sketch that out real quick. But actually, before we do, some other information we can kind of grab. Y-intercept is going to be at 1. Oops, excuse me. The turning point, so we know that's when x is 1. So if we substitute that into our original equation, we're going to have the y value of 3 times 1 squared takes 6 times 1 plus 1. Oops. That's going to be 3 take 6 plus 1. It's going to be 3 take 5. That's negative 2. So we know the turning point is going to be at 1, negative 2. And we've got our roots, so that's everything. Sketching out a quick, yeah, you get the idea, quick axes here. We see that our midpoint is going to be, or our axis of symmetry rather, is going to be when x is 1. And we can see that we're about 2 root 6 over 6 above or below that. So I just want to kind of estimate what the value of 2 root 6 is. So on my calculator, I'll see that it's about 0.8. It's about 0.8. So if I'm 0.8 below 1, I'm still going to be in the positive x domain. All right. If I'm 2 root 6 over 6 above, I'll probably be about there somewhere. But it's important that we kind of, we're making sure, you know, we're putting our roots where they're supposed to be. So if I've got an estimate of this value being about 0.8, I know that 1 minus 0.8 is still going to be in a positive x domain. So this is going to be 1 subtract 2 root 6 on 6. This is going to be 1 plus 2 root 6 on 6. What I'd prefer you guys doing is just, you know, simplifying that on your calculator and then just giving me this as a decimal point. Unless, of course, it's non-calc, then just do what I've done here. We saw that the turning point was going to be at 1, negative 2. So we'll just say negative 2 is here. So turning point is going to be somewhere around here. And the y-intercept was at 0, positive 1. So let's just say that's about here. Alright, so we're coming down through this y-intercept, down through our root to our turning point. Hitting our turning point, coming back through the other root here. Let me try this one more time. Good enough. So that's a sketch of this second parabola here. The key thing is we've got all of our key points, right? So we've got our turning point, which implies our axis of symmetry. We've got both our roots, and we've got our y-intercept. So as long as we've got all those 4 key features, well, 5 if you want to count the axis of symmetry, when we're sketching out our parabola, we can consider it to be correct. It might not look perfect because our scale's kind of whack, but if we've got the key features labeled, it's correct for a sketch. Anyways, that is all. Bye.